will open up for questions, and there is an icon at the top of your screen. You just click there, and then we take your question. So feel free to ask questions and comment and give comments to our presenters. So we have a question here from Andrew Jones.
Yes, this is for Ian Banks. You mentioned varying your larval densities. I saw you gave numbers. Could you give me a little better feel for how big the containers you were working with in terms of surface area and volume?
Okay, so as I said, the smallest containers were getting 140 grams of food a week, and it was a matter of getting the feeding depth standardized. So I fed them at 5 centimeter depth and then moved the divider out. The biggest containers were getting 1.6 kilos, and they were big enough for like 4 or 5 weeks worth. So they were 2 foot by a foot long. They were big containers, yeah. But as I said before, those ones, there was a large amount of residue left over.
Mm-hmm. And so you said the depth was more important than the surface area or the volume?
So we couldn't standardize both depth and surface area for this experiment because of the 27 different combinations, yeah. But that is something that I was wanting to look into also, and that will be looked into in the future. Yeah.
Thank you.
Yes, thank you, Andrew. Any other question? Stefan, do you have a question?
Yes,
please go ahead.
Thank you. Hello. Thank you, Ian, for the nice presentation. Very interesting indeed. About your experimental setup, you said you fed them once a week. Do you think this might have influenced the matter of this low waste reduction ratio you had? You said you had a lot really fat larvae, but the waste reduction was not that good. Could this be connected to this enormous amount of feed you fed them at one time?
Yes, it will be linked to the, well, as you know, the feeding rates with the larval density, it's exponential really. If you have the 1,200 larvae with the higher feeding rate, you're twice the amount of material. So the feeding rates were, we know that basically the 100 milligrams per larvae per day is, at least with municipal organic waste, the most effective, most efficient. We were trying to determine the extremities of their effectiveness with waste reduction and pupil production. So we knew that the 1.6 kilos a week was going to be too much, but we wanted to determine just how much waste would be left over with that. Does that make sense?
I think I made the experience that if you feed them on a regular basis, like let's say daily or every other day, they are able to feed on the surface of the material. And if you just put in a lot of waste at one time, they drown somehow underneath this big package of waste, and the upper part builds up an impermeable layer where they have difficulties to feed on. It was just a thing to my mind.
Yeah, actually, that was one of the things with the moisture content. With the 65%, they'd burrow through it, and they would, it would be relatively dry already, so they would be able to burrow through it, and the tunnels, so to speak, they dug would maintain their shape. But with the 75% and even more, the 85% moisture, they stayed on the top, moving around constantly until they dried it out enough to get down. But then a week later, they'd get another load of food. So yeah, it was a bit, it felt sorry for them, yeah.
Yeah, I see that there's a lot of questions going to Ian, showing that that's a very interesting subject. Then we still have time, and there's our participants from Ghana turned down their video. They are still available for questions. So we have Andrew Jones again.
Hey Ian, did you experiment at all with getting black soldier flies to mate indoors, or is the environment such in South Africa that they can mate outdoors all year round?
I don't know how much I can actually talk about that specifically. The people I was working with are a company, also, well, it was Biocycle and Ag Protein, so I don't know how much I can really speak about their possibly proprietary technologies, I'm afraid, sorry.
No, that's fine, so you were raising them inside?
But they were being reared indoors, yes.
Okay, gotcha, thank you.
Okay.
I'm just taking up from a question from Carol Maguire. You had a question in the chat about the pit being dry. That is it that the pit is not in use, or is it a urine diversion dry toilet?
None of them were urine diversion toilets. They were self-built, non-improved pit latrines that the household owners built themselves because they weren't happy with the government-provided latrines. And the area that I collected in was they had a very low water table, and I think the pits themselves were just very dry. The material, when I emptied it and homogenized it all together, it was at 65% moisture content. Which was very different to later work I did in the Eastern Cape, where I struggled to find pit latrines that weren't flooded or weren't waterlogged. Yeah, but they weren't urine diversion. No.
Thank you, Ian. Any further questions to our presenters?
There's a chat question from Laura Kamani. Laura works at Sanergy in Kenya, and she's asking the people in Accra whether they can tell us more about the composting time prior to pelletization. And then the other part of that is what other carbon sources are added beyond just the fecal material. Like, are there in fact undigested sources of organic carbon? So I'm not sure if the Accra people can hear this.
We started already the question. So for the composting, we have an average duration of 3 months. And
sorry, you said 3 months?
Yes, 3 months in average. And
for
okay.
3 months for composting time.
Sorry?
You said 3 months for composting.
Yes.
Okay.
And in terms of other additional organic waste, different sources tested already sawdust. We have used market waste, household waste.
Okay, some food wastes, is that what you're saying? Okay, that's the answer to Laura's question. And I think there are, what, 2 more questions, Nelson?
Josiane? Yes, Håkan and Elizabeth in that order.
Yes.
Håkan, go ahead.
Okay, this is a question to Steve about this drying membranes, and I'm interested whether you have looked into the possible environmental impact of this type of hydrophobic substances. There is a worry in Sweden if you get that into the environment. They are really difficult to degrade, and I think they also actually bioaccumulate. Have you looked something into that?
Well, it's quite unrelated to our direct research. I'm familiar with some of those concerns. They're actually more related to some of the very hydrophobic solvents that are used in manufacturing these materials. We would picture a system where after these fabrics are used and at some point can't be used again, perhaps they fail physically after multiple uses, they could then be sent to a recycling disposed of properly, and they are not biodegradable, but there are ways that they can be reused by being sent back to a manufacturer. These materials are used in many other applications. They're used in camping wear, they're used in sailboat sails, they're used in a lot of other places as well. So the small amount of material that we would imagine using for these applications, I would say that the environmental impact in terms of sanitation is a lot more positive than possible side effects of their non-degradation.
But still you would get it into the fertilizer? No.
The fertilizer is separate. It doesn't adhere to the fabric. The fabric is the enclosure. It's like a big, you might use it even as a large bag that contains the material, lets the water go out. When you're done with it, you empty it out. You can compost this dried material. You can use it in other ways that you might want to. The enclosure or sack itself, you put back into the pit or into the drum or whatever and use it again multiple times.
Thank you, Steve. Elizabeth?
Yeah, I just have a follow-on question for Steve as well. So when you say multiple use, then for your application 3, where you have the pit latrine on top and the drum at the bottom,
right?
Let's say it takes about, let's say 3 months to fill that drum, then how many times do you think that bag could be used? You say multiple use, but is it like 5 times 3 months or 10 times, or how long would it last?
Yeah. Well, the graph that I showed in one of my slides showed it being reused 5 times. After the 5th reuse, it had lost about 3% of its permeability. So at least in our lab tests, it could be used almost indefinitely. I did some calculations. I think it was at least 20 times, but we're talking using it 3 months at a time. That would be many years of reuse. So
yes, Steve, there's a question here from Richard Fisher.
3 months, that's already, yeah. Okay.
Yeah, there's a question from Richard Fisher. He wants to know at what condition you run your drying tests, temperatures on either side of the membrane, relative humidity, etc. And also asks if you have to supply heat to the waste side of the membrane.
That's a good question. There are 2 ways you can get water through the membrane. Well, both of them have to do with having a different water vapor pressure, a lower one on the side where you want the vapor to go toward. You can do that even if there's water on the other side of the membrane. If it's at a higher temperature, there's a lower vapor pressure. So, no, I'm sorry. A lower temperature means a lower vapor pressure. So if the waste is warmer due to biodegradation or solar heating, then you can actually dry the fecal sludge, even if it's even if the soil around the pit, for example, is water saturated. The water will be transferred from the fecal sludge to the cooler temperature water. But the other way is to have air on the other side, because the vapor pressure is going to be a lot lower, and it's equivalent to drying, but you have a membrane in between that keeps other things from going outside of the membrane. So the tests that we've run, we have run many tests simply at room temperature. We've done tests at an elevated temperature, but on both sides of the membrane, and we have done tests with temperature differences of 2 degrees, 5 degrees, and 10 degrees Celsius. And of course, the drying is faster when you do have the temperature difference, but the best way to use this is to have the waste, the fecal sludge on one side of the membrane and air on the other side. That gives you a lot faster drying than the small temperature difference in having water on the other side, like a water-saturated soil.
Thank you, Steve. Elizabeth, you have another question there.
Yeah, it's a bit hard to jump from the one topic to the other, but I'm jumping back to the black soldier fly now. I'm just wondering, this research has been going on for a while, it seems. Different groups have been doing it, and where are we at in terms of commercialization of this? I mean, there's this company in South Africa, but I couldn't really figure out, are they making a profit yet, or is it still piloting? And then I know that in Sweden there is some companies. Is there some sort of, like, it always sounds promising, but it never goes anywhere? I have that feeling. Is there something that is stopping it from really being commercialized?
Okay, so the people in South Africa who are working on it are Biocycle, and they have up and running their pilot plant at the moment. So it's a proof of concept plant, and they're collecting bucket toilet material, pit latrine material, and processing it on site there. There's still, as I mentioned, there's still a lot of work that needs to be done to get an end product that is known to be safe before you can start just rolling it out to rural settlements and hoping that there won't be any transmission of disease or any other problems that are caused. So there's still work that needs to be done on this, like as I said, but yeah, it's not far off. In the next couple of years, I can see it actually taking shape a lot more.
Thank you, Jan. The time is 5:30 Swedish time. We still have questions coming in from Håkan and Björn.
One thing? Can I just add
Yes,
to
please.
the comment on the black soldier fly? For Europe, the problem with the black soldier fly is that it's considered to be a production animal. And as a production animal, according to the EU regulation, it's forbidden to feed a production animal to another production animal, according to the animal byproduct regulation of the EU. So it's in Western Europe. It's at the moment it's not possible to feed insects to animals. So if you have the intention of producing animal feed, you cannot do it at the moment, but it's a lot of lobbying groups working on it. So hopefully it will change within the coming years.
Yeah, very interesting.
You have to start eating it yourself, Björn.
So yeah, Håkan also had something.
Let me see the microphone. Yeah, it was the same thing as Björn said, and that's why we don't have any commercial. Or that is of course one important reason why there's no sort of commercial production in Sweden.
Yeah, that's a very interesting contribution there for our audience. So the time is 5:30. Any more comments, questions?
There's a question from Stefan.
Stefan, please.
Yes, I just want to add something to what Björn just said. It's not only that you're not allowed to feed larvae to other animals, it's also the fact that you're not allowed to feed waste to farmed animals. And at the present regulations, larvae which you are raising commercially are looked at as farm animals. So there is also a barrier regarding the takeoff of this technology. But as Björn said, there's a group lobbying to change these regulations.
All right, thank you. But Ian, is there any restrictions in South Africa in this regard?
As far as I know, there is still some restrictions on what they can be fed. I think a lot of it's related to BSE, scrapies, so yeah, there's still issues with prion transmission. But there is less regulations as far as I know. I'm not too sure about this, but I know that the company AgroProtein has a, what's it called? A patent, not a patent, a license for producing, I think it is, mag meal, which is animal feed made out of black soldier fly larvae, made out of maggots, basically. So I think the restrictions are slightly less than they are in the EU, but I don't know all of the details of that.
So thank you. Any further comments before we round up? It's 5:35 here in Stockholm. So I think that there's no more comments. Anu?
Okay. Well, I think I learned a lot this time. You know, we've learned about something called Fortifer, which is a pellet that can be produced from the treatment of composted materials originally from fecal sludge. We heard about that from Accra, Ghana, and we learned a lot about the black soldier flies and what they can consume and what's the ideal population control densities from the work in the London School, but also the work in South Africa at the same time. And then we heard about the vapor-permeable membranes, these being some interesting ways of drying pit latrines, and I can imagine them being applied in some of the larger silos that Sulab is operating in India. I thank the speakers and all the attendees. We have a record number this time over, and if you wish to continue this discussion on the Susanna Forum, please do so. You can go to the website and you can be a member if you're not already, and then contribute on the Susanna Forum, and that's the forum.susanna.org. The next webinar in this series will be held on the 8th of April. So without any further ado, we thank you for your participation and say goodbye. And if we just lift our hands there, that'll be the proof that we're still alive here and kicking. Okay, goodbye.
Yeah, goodbye.